So before we look at this chart, we do need to take a look at the periodic table and just get a couple things clear looking at the whole table. So how is the periodic table organized? And in 6th grade, what we're most concerned with is coming to understand how the periodic table is organized in relation to specifically the first 3 periods of the periodic table. So if we look at the periodic table as rows of elements, and we look at the periodic table as columns of elements, there's some unique things to understand. So first of all, we're going to just call this period 1. We're going to call this period 2, and we'll call this one period 3. And that simply means that this row across here is period 1. This row, including these elements, would be period 2. And this row of elements in the periodic table would be period 3. And so we basically are looking at, there's a period 4, there's a period 5, period 6, period 7, and so forth. And then there's some other things that are going on down here where these guys here actually kind of fit into these rows, and it's kind of complicated, so you don't have to worry about it. But it's like this is kind of like all of this stuff here goes up into this, up into these squares, and so you don't really have to worry about that. But let's look at this, at what the periodic table actually tells us about the atoms of the different elements, because we're concerned about understanding the elements and the atoms in relation to the density of matter. And so when we look at the periodic table, we see that when we follow across in the rows of elements, we see that we actually have ordinal numbers. Ordinal numbers meaning numbers that count up in order. So we see hydrogen has a 1 there, we see helium has a 2 there, we see lithium has a 3, and beryllium has a 4, and boron has a 5, and carbon has a 6, and nitrogen is 7, and so forth. And all of these numbers, we notice, all of these numbers, they count up in order. All of these, they count up in order. So we're looking at these numbers going, what in the world? I mean, so why is the periodic table, why are the periods set up like this? So we find that period 1, which contains the elements hydrogen and helium, period 1 has the elements with atomic number 1. These, by the way, are called the atomic numbers. Atomic number 1 and atomic number 2. So period 1 elements are hydrogen and helium. Those are the only 2 elements in period 1, in row 1, or period 1. And then we find that lithium, which has an atomic number of 3, beryllium, which has an atomic number of 4, boron, which has an atomic number of 5, carbon, an atomic number of 6, nitrogen, atomic number of 7, oxygen, an atomic number of 8, fluorine, an atomic number of 9, and neon, which has an atomic number of 10, we find that these elements are period 2 elements. These are the elements that are in the second row of the periodic table, and we call them period 2 elements. So period 2, again, period 1 elements. And then period 3 elements are also numbered in order and have corresponding atomic numbers. So what does the atomic number tell us about an element? And so about the atoms that are in an element? Well, it just so happens that the atomic number actually tells us how many protons are in the nucleus of a given atom. So Mr. Woods, are you saying that I can just look at the periodic table, and by looking at the periodic table and looking at the atomic numbers, I can tell how many protons are in an atom of that element? And that's exactly what I'm saying. So how many protons would be in an atom of lithium? There would be 3 protons. How many protons would be in an atom of hydrogen? There would be 1 proton. How many protons would there be in an atom of oxygen? There would be 8 protons. How many protons in an atom of carbon? There would be 6 protons. So, Mr. Woods, so you mean all these atoms, all these elements are put in order in the periodic table in the order of the number of protons that are in their atoms? Well, how cool is that? That's really quite cool, because we can know by counting the number of protons in an atom, we can know what element we're looking at. So if I'm looking at an atom that has 10 protons in it, that atom is going to be an atom of neon. If I'm looking at an atom that has 13 protons in it, that atom is going to be an atom of the element aluminum. If I'm looking at an atom that has 16 protons in it, that atom is going to be an atom of sulfur. Now, we have this term you've heard me use already, and I'll be honest with you, in science, Miss Brinkley would probably say, Mr. Woods, why are you using that? Well, I'm going to use this term to just make sure that we're clear in the type of atom we're talking about. Because remember, there are a couple of types of atoms, and the 2 things that we talk about in 6th grade are an atom that I'm just going to call a pure atom of an element, and then an atom that we understand to be an isotope. And so we understand an isotope to be an atom of a given element, but it doesn't have the same number of neutrons in the nucleus as there are protons. Now, a pure atom, the same number of neutrons as there are protons. So there is a difference. These are not the same. They are the same element if they have the same number of protons, but they're not the same type of atom if they have differing numbers of neutrons when compared with the number of protons. So what we need to do is we need to learn. Let me show you this other. Let's look at this for just a moment. Let me kind of clear that screen so we have all that stuff off of there. What we need to be concerned about when we're thinking about the periodic table, and I'm just going to give this to you, we need to be concerned about the particle count. So what do I mean by that? Well, how many protons are in a given atom and how many neutrons are in a given atom. And when we look at and we compare the number of protons with the number of neutrons, we're going to easily be able to see whether a given atom is an isotope of that element or whether it's actually a pure atom. And again, the word pure, isn't it isn't a word we use in science to describe, an atom of an element that has the same number of protons as neutrons. But I'm going to just use it for a while we're getting used to it. So a pure atom is an atom that has the same number of protons as it has neutrons. An isotope is going to be an atom that has a different number of neutrons than it has protons. And all of this has to do with coming to understand the particle count for any given atom. So if you take a look at this periodic table, you see we have the let me get a different color. We actually have the there we go. We have the atomic numbers. It's the same as we did on the other periodic table I was showing. We have all these atomic, but then we have these other numbers down here. They're like, Mr. Woods, those numbers down there are like decimal numbers with a lot of decimal places after them. What do we do with those numbers? How do we understand what those numbers are? Oh, look, there's one that has a 4.000. Mr. Woods, why don't we just call that 4? Why isn't that just, well, I'll just give you a little clue right now. These numbers down at the bottom, these are actually the atomic mass of these elements, of atoms of these elements. Oh, Mr. Woods, so what's the atomic mass? Well, the atomic mass is actually the particle count of any given atom that we might be considering. So let me just clear all this off of here, and let me just get this clearly written. So we have, let me do this in green. So we have particle count, tells us the atomic mass. And so how do we determine the atomic mass? Count the particles in an atom. And the number of particles in an atom are how many, the number of particles in an atom is the particle count of that atom. And that tells us whether the atom, first of all, the number of protons will tell us what element it is, and the number of protons and neutrons added together or counted together will tell us whether that's a pure atom or whether it's an isotope. And so let me just wrap up this video, and then I will go to the chart that I was talking to you about, and we'll take a look at the difference between pure atoms and isotopes in a manner that will help us to a little more easily understand the difference.